All right, hey Libby and Angel, this is 4-6. There's the homework assignment for it. There's 4 problems. We're gonna get through like a couple problems today. We won't get through the rest of the notes, but we're gonna try to do this page, example 2 and example 3, and we're talking about not only graphing like the position function, but also graphing the velocity and graphing the acceleration, and see what those graphs look like and interpreting those. Okay, so that's what we're doing for this one. Eli, are you ready?
Yeah.
No. He's lying to me. Okay. Example 2. Here we go. We have a position function. This is my cubic function. This is where my ant is traveling. Yeah, like my little ant going down the hill and stuff. He is following a cubic path, okay? Now, they're only graphing, so I'm going to show you what this cubic function looks like. They are only graphing, like, they're neglecting the left half of it because we're starting at 0, being a time of 0. Okay, so this is my position function. So my ant is starting, my little crawly ant, he is starting like at ground level. He's going underground, and then he's at 6 seconds, he's right on the top of the ground, then he goes up the hill again. Okay, so that's what my ant is doing. Okay, he's following along this curve, which is t to the third minus 6t squared. I'm going to write that down here, and then we are going to find the derivative of him and compare what's happening with that, and looking up like at the velocity. Is the velocity speeding up? Is the velocity slowing down? That type of thing, okay? So if I find s prime of t, which is the derivative of the position function, that is the velocity, yeah? Okay, the velocity will be 3t squared minus 12t, yeah? So now I'm down to a quadratic function. Okay. Normally, we don't graph the velocity function or the first derivative. We don't usually graph the velocity. We plug numbers in to see if it's increasing, decreasing, that type of thing. Okay. But now we're going to be graphing this velocity function and showing you what the velocity is doing. Not where the ant is at physically, up and down the hill, but what's happening to the velocity. Okay. So here we go. When we're looking at this, so I'm going to compare these two graphs to each other, right? Okay. My ant is going down the hill and then he's coming back up. Okay. Now, one thing that I look at is like if I pick this point here, right? And I draw a tangent line, that tangent line is going to have a negative slope. Agreed? He has a negative slope for a tangent line, which means that my velocity is going to be negative. Now, that doesn't mean that my velocity is slow. That just means at that point I am going downward. I am going in the downward motion for velocity. So until I get to here, I am going down in that downward motion, right? Yeah. Well, I guess I'm negative, so I'm actually negative from here to here. So until I get to this point on my curve, I am going down underground, right? Then at this point, right here, now my velocity is positive because I'm going back upward. Does that make sense?
Yeah.
Okay, at that point, at 4 seconds, I turn and I'm going upward. So I'm still underground, but I am now going a positive velocity because I'm going in the upward direction rather than going in the downward direction like I was to begin with. Does that make sense?
Yeah.
Okay, so that's the difference between those two graphs, okay? Now, where is my velocity the highest?
The top of it.
Like up here at 6 seconds, because my speed is going, like my velocity is highest at 6 seconds. No, right here. My velocity is highest at this point, okay? At 6 seconds. Now let me show you. This guy, in the middle of my path, I'm really, like here, I'm down at the bottom of the hill. Then I'm speeding up. At this point right here, I'm going pretty fast because I've already sped up, right? I'm at ground level. I'm now got my momentum to go up the hill. That's why this is at a high place, is because I have sped up and I'm going my highest velocity to get up the hill. Does that make sense? Okay? So that's why he is highest. Now,
I think you go slower.
When you go up, wouldn't you go faster going down?
Possibly. But we don't necessarily know that this is an ant. True.
Got it.
Yeah, I mean, I just made that part up. So yeah, his velocity. Now, my velocity when I'm going down the hill, so I'm going down, yeah, I'm kind of like slowing down as I go down this hill because my velocity is back to 0 by the time I get to the bottom of the hill. So I'm kind of slowing down. Your velocity is the same at 2 seconds as it is at like 5 seconds. Do you see that? At 2 seconds, I'm going this for a velocity. At 5 seconds, I'm going at this for the velocity. But what's the difference between 2 seconds and 5 seconds?
Going down.
I'm going underground. I'm going underground here versus above ground here. But both of those have the same velocity. I'm going the same there. Okay. Now, they then also went and took that velocity curve and they changed it to a speed curve. What's the difference between velocity and speed?
Speed is never negative.
Speed is never negative. So they just took this little part here and they flipped him. They reflected him across the x-axis and he looks like this. So now I can see speed in positive terms, right? So I'm speeding up until I get to this point. Then I'm slowing down until I get to this point where I've stopped and now I'm not going any speed at all before I really increase my distance when I'm going up the hill. Got it? So sometimes it's easier to look at speed rather than velocity because they're both, everything's above the x-axis. Got it? Okay. It says find the velocity and speed functions. Okay. Here's my velocity function right here. 3t squared minus 12t. What is, speed. I shouldn't call it s of t. What should we call speed? I'll just say speed of t.
SP of t.
Speed of t or sp of t is the absolute value of that, right? Because it's only above the x-axis.
So S.
That's what those absolute value bars do. It flips them, okay? So I have found my velocity function. I found my speed function. We've graphed them here, and we've kind of like talked about what those things mean. So find velocity and speed functions. Show the graphs of the position, velocity, and speed versus time. We've done that, okay?
Yay.
They did that for us.
We're
Hey,
halfway
look at that.
done.
Look at that.
Wait, hang on. Hold
Okay.
up, hold up, hold up. Speed of t
Yep. Speed of t.
is equal to 3, absolute of 3t squared minus 12. Because you can't go a negative speed.
Right, true. Okay?
So, wait. So our velocity is only the second graph?
Yes. Then speed is the third graph. Because they've flipped this bottom guy to the top.
Okay.
Okay, before we do acceleration in example 3, I'm going to go down to this little chart and talk about him for just really quick. So go to the last page.
Oh,
Go to the last page really quick.
Bob.
I'll hit this again tomorrow, but go to the last page. This is the position function. What?
Nothing?
Okay, here's my two graphs. They're both above the x-axis, so my ant is going uphill, right? My ant is going up the hill, okay? This curve has a positive slope, so if I look at this spot in particular, my velocity is positive, right? Here, I'm going downhill, my velocity is negative, okay? So let's talk about what this means. The curve has a positive slope, the curve is concave down, okay? The particle is on the positive side of the origin, so I am above, like I'm going up the hill. Here I'm above I'm above ground on both of these, but one I'm going up the hill, one I'm going down the hill, okay? Here my velocity is decreasing in the first one. My velocity is also decreasing in the second one, okay? Like I'm slowing down.
Oh, because you're concave down.
I'm slowing down. Okay, the particle is slowing down. The particle is speeding up.
Wait.
Hold
How
on.
is
Hold
velocity
on.
decreasing if the particle is speeding up?
Velocity is decreasing. The particle is speeding up. That's confusing to me. Hold up. Particle is moving in the negative direction. Particle is moving in the positive direction. Velocity is decreasing. The particle is slowing down. Velocity is decreasing. The particle is speeding
so
up.
both are concave down, so both are decreasing. Velocity is decreasing. And is it because the slope is positive that it's slowing down?
As you're going
Explain
down
this
the
to me.
hill, you're going to go faster. So your speed is going to go faster, but your velocity is still going to be more negative. Like if you draw like a tangent line down here, it's going to be more.
Oh, it's going to be more up and down. Yes, I agree with you. Yes. Okay, so what
That
Reese is
makes
saying,
sense.
okay, I got it. This dot in comparison to this dot. This dot is more straight up and down than this one, right? So the fact that this guy is more straight up and down means he is slowing down, right, as I go along. But this dot versus this dot, this guy is more straight up and down, which means he is speeding up, right? Okay? Yeah?
Yeah, I get it.
Yeah.
I get what you're saying.
Because, okay, even though my velocity is decreasing, check this out in this graph up here. My velocity is decreasing. My velocity is going downhill, but guess what? I am going faster here than I was here. Yeah? Like at the bottom of that hill, because this is the absolute value. When I look at it in terms of speed, his absolute value is higher than what this dot was. So even though I'm decreasing my velocity, I'm actually speeding up. Yeah? Okay? Because velocity is positive, negative. Yeah? Okay? All right, so that's how that works. Okay, got it. All right, these last two. Got it? Okay, these last two. This is where I'm underground. So this guy, his curve is negative. Okay, he has a negative slope. He is concave upward. Let's talk about this. The particle is on the negative side of the origin. I'm going underground. The particle is moving in the negative direction. That's what we said. The velocity is increasing.
Because he's negative.
Because he's negative.
Here.
Because he's negative.
Down.
But the particle is slowing down. Because he's going from he's going from a steep slope to a not steep slope. Yeah?
Yeah.
The steeper the slope, that means he's speeding up. If he's going toward a flatter slope, that means he's slowing down. Yeah? Yeah.
I get what you're saying.
Flatter slopes mean he's slowing down. Steeper slopes mean he's speeding up. Okay? All right, this one, we're at the top of the hill, which means my curve has zero slope. The curve is concave down, whatever. The particle's on the opposite side of, the positive side of the origin, which means I'm at the top of the hill. Particle is momentarily stopped. Do you see that?
Yep.
I am momentarily stopped, but they say that my velocity from here is decreasing because here I'm at a flat, right? And now I'm going like downhill. But wait, shouldn't that mean that my velocity is... Oh, it has been decreasing. My velocity is decreasing up to this point.
No. Your velocity is decreasing, but you're speeding up. You're right.
I'm
you're right.
confused again.
No.
Okay?
Your velocity is decreasing because you're going down, but you're speeding up because it's steeper the slope, and you go farther down. That makes sense.
Yes. Yes, my velocity is decreasing. Yes, okay. Good. You want to just teach this? This is hard for me to see. Okay, let's go to example 3.
That's why you say
Let's look at acceleration.
Don't worry, Eli. I am.
Hey,
Hey, you said no. You said 2 and 3.
Yeah, we
We're
haven't
not
done 3
with
yet.
3.
We haven't done 3.
But you're also speeding up. It doesn't make any sense.
Your velocity is decreasing,
You're be on this page.
but that means you're speeding up.
So as you're going down, your velocity is
Those charts were difficult.
Right?
your velocity is
okay, like-
decreasing, but your speed is
Okay,
increasing. because you're slow.
think of me dumping something off of a cliff or like parachuting out of an airplane, right? Here's my airplane. Okay? My velocity, hold on. Okay? At, let's say here's where I'm at. Okay? I'm falling toward the earth. Maybe here I'm going negative 16 feet per second, and that is my velocity, yeah? Okay?
You're going 16 per second.
But down here, as I fall toward the earth, I'm going negative 64 feet per second, right? Technically, that is a decrease, right? Because negative 64 is more negative than negative 16. That's a decrease.
Why are you
But-
writing it in minus?
Because I'm falling toward the earth. Velocity as you fall toward the earth is negative.
Because
Okay.
of gravity.
So, since negative 64 is more negative than 16, it is decreasing velocity, right?
Yes.
My velocity is decreasing, but am I going faster than what I was before?
Yes.
Yes, so a decrease in velocity when I'm falling toward the earth means I'm increasing my speed. Does that make sense?
Yes.
Because velocity toward the earth is more negative. That's better. Yeah? Maybe? Ish? Okay.
Booth said he didn't care. It was
Booth
positive.
doesn't know what he's talking about all the time. Okay.
Yeah, literally. Change
Oh,
it
I
into
took it of this chapter, how many times he talked about cars.
We have tally.
I had to be a lot this chapter.
Oh gosh.
Oh, 10, 13 times.
You know, he relates everything to cars.
When it goes on
Yeah.
a tangent about cars.
I don't understand cars, so it makes me more confused about the topic. Like I get the topic and then he relates it to a car and it just
I only understand like the engine part from Bond's class, which is really surprising. I don't learn anything.
Okay. Here is the progression of how things work. So we just talked about this is where the position is. Position. This is where my S of t is position. That's where my ant is located at, right? But if I take the first derivative of S of t, that's my velocity. Okay? If I take the absolute value, I'm going to say abs value equals speed. Okay, so if I want to look at speed, I would do the absolute value of the velocity instead. But if I take the second derivative, that will tell me what my acceleration is. Right?
Hang on.
How I'm
Velocity.
accelerating.
Absolute value of is speed.
Absolute value of the velocity is your speed.
That
Okay?
makes sense. I get
Yeah?
it.
Yeah?
That-
And then if you take the second derivative, that's your acceleration, how your thing is
Yeah.
accelerating, okay? So example 3, we're talking about acceleration. So here is my position function again, same position function as I had before. So I'm just going to write this all out. S of t equals t cubed minus 6t squared. That's my position function. If I do the velocity, that is s prime of t, which is 3t squared minus 12t. Okay, that's the second graph that we looked at. Okay, if we wanted the speed, we would do the absolute value. Now, if I want the acceleration, like how I'm accelerating, right, that is the derivative of the velocity, which is the second derivative of the position, which is 6t minus 12.
Can't. Six.
Wait,
S
what?
of t is equal
Oh,
to
yeah, yeah, yeah.
t3 minus 6
Yep, we got
t
it.
squared.
Okay,
Got
So
that.
then v of t is equal to 3t
Acceleration
squared minus
versus time.
12t.
okay.
And then
How can
a of
acceleration
t
be negative?
is equal to
I don't know.
6t
Hold on a second.
minus 12.
6t minus 12. 6t minus 12 is a linear function. They've graphed it here.
Alright,
Okay.
go back.
All right.
Deceleration.
What?
Wait.
Am I decelerating?
Oh yeah, right.
Yeah, because you're slowing down.
You're slowing down. It's negative.
Yeah, I buy that. Okay. So this chunk from here to here, this is where I'm how do you spell deceleration? Deceleration. I don't know if I
It's
spelled that
just
right.
one- It's just one.
Deceleration. It's just one C?
Yeah, I think
Okay.
Wait, no, because that's going. That's kind of.
Because he's negative from here to here. That means I'm in negative acceleration, which is deceleration. I'm slowing down at that point. Okay. Let's see if that's consistent with my thing up here. Okay. Am I slowing down from here to here?
Yeah.
Am I slowing down from there to there?
Oh gosh, no. I don't know.
Yeah. Aren't you? You're
I'm
going
slowing
this
down.
way. You're going this way.
How the heck
Yeah.
are you slowing down when you're going down a hill? You do not slow down when you go down a hill.
You're going negative.
But you're going down a hill.
Yeah,
But
but
it's below but it's below the x-axis.
am I slowing down between 0 and 3 or 0 and 2?
He's negative on the
Acceleration
y-axis.
versus time.
No, wait.
If he was above, if he was on the positive
No, but it doesn't make
y-axis.
sense because you're going down a hill. You're accelerating when you're going down a hill.
But like, are we thinking about it as a hill?
I
I
don't
don't
know.
think it's a hill.
I don't think it's a hill.
Okay, so we can't have that ant be the whole time.
We're not.
I know, like the whole ant concept is kind of hard to
It was
like.
good at first.
It was
now
a
we
good
need to-
ant
we
concept, but
to
now we
move
need to
away
do
from
something
it.
else.
Yeah, we need
So
to
We
what-
need to like
what
talk
is
about
it?
a vehicle or
So what
something
is
now
it
instead.
now?
You're gonna have
But
to
a
talk
vehicle
about
can't go
cars.
underground is the problem.
No.
See, position. How can position be negative? You move backwards.
No, like
You go down. You did that.
you're underground. I don't know.
We just said the ants don't. The ant thing doesn't work.
Shoot.
I'm gonna say that it's
How are you gonna go into the
accelerating
ground?
because it's in the ground.
How are you going to you know below sea level?
Okay.
Okay, let's just look at this part of the graph though.
We have like 30 seconds. Yeah.
Oh shoot, that's the bell. Good heavens. Okay, we'll talk more about this tomorrow. I'll leave something for you.
That literally makes no sense.
I'll unconfuse you in the video that I leave for tomorrow. Okay, goodbye people.